Okay, good morning. Welcome back. This is Geography 10, Lecture 10. Today we're going to talk about the Arctic, a part of the world that otherwise doesn't get much attention this semester, but which is worth paying some attention to. This will also allow us to pick up some of the things that we just barely touched last time discussing Terra Preta about carbon and global warming. So we're going to talk about the Arctic and climate change, and then try to relate that to questions of sovereignty, property, and territoriality. In many ways, well, there's a depressing part of the story about the Arctic right now, and then there's sort of an exciting part, and the exciting part is the part in which the world is trying to figure out what the territoriality of the Arctic should be under the new circumstances in which suddenly we can attempt to exert property claims or have a reason to exert property claims there, and therefore also sovereignty claims. First, quick update. The reading for Tuesday is from your atlas, pages 32 to 41. We will spend lecture on Tuesday having a review session. As I said last time, please come to class on Tuesday with questions that you would like to hear answered or topics you would like to hear discussed further. At the beginning of class, I will take those questions from you and put them on the board, and we'll decide which ones to treat or which ones to treat first together, and then we'll discuss them, okay? Finally, the midterm will be on the following Tuesday, March 9th. We'd ask you to bring a blue book and a pen for the midterm. A black or a blue pen, please. I also think we need, do we not need to ask some volunteers to go to 575 instead of here for the midterm? How many do we need? About 10? Okay, I need to, if you are a DSP student, you will take the midterm not in this room, but in room 575 in McCone Hall. That's the big seminar room at the end of the hall on the 5th floor. I also need to ask for roughly 10 volunteers who are not DSP students to volunteer to take the midterm in 575 McCone instead of here, so that we have enough seats in this room for everyone. Believe it or not, there will be a shortage of seats. So if you're willing to take your midterm exam in 575 McCone, please raise your hand now. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10, and you have to remember who you were, right? I didn't get your names. Plus the DSP students, please go to 575 McCone at this time on Tuesday the 9th, okay? With a blue book and a pen. The midterm will look something like this. There will be essentially a map quiz built into the midterm. And it will cover North and Central America, and we will post those items and map to BSpace a week before the midterm. We will also take one of the reference maps, which is to say one of the maps we have already used for a map quiz, and we will reproduce it in the midterm. And then we will ask you a series of questions that will require that you still remember what you remembered when you took the map quiz, okay? So instead of asking you to put certain place names on dots or on countries on the map, we will ask you questions like, which two countries border such and such river? And you will have to look at the map, find the river, locate the countries, and remember what they're called. Okay? That kind of thing. So that will be the first two sections of the midterm. Probably take, 10 minutes apiece. There will be a section of basically ID questions or definition type questions. Questions where you can answer it almost by filling in a blank or by writing a single sentence. There will be a couple of short essay questions where you're asked to write maybe 1 or 2 paragraphs. And then there will be one longer essay question that will take, say, 4 or 5 paragraphs to answer. And for that one, I expect that there will be like 2 questions to choose from, and you'll get to choose to answer one of them. Any questions? Yeah. How many short essays will there be? Probably about 4 of them, something like that. Yeah.
Do you happen to know how this will be graded in terms of point distribution yet?
How will it be graded in terms of point distribution? Boy, I probably could answer that precisely if I looked at an actual exam. Off the top of my head, I want to say that the 2 map quiz type things, the 2 first sections together, will probably be worth about 20%. Maybe 25. I guess when you get down, probably like 25% for the maps, and then maybe 15% for the IDs, and then that would get us to 40. Then I'd want to say probably 30% for each of these last 2 sections, something like that. There was another question, I thought. Maybe it's already been answered? Okay. Today, the reading for today was the last couple chapters from Crosby. And I'd be happy to discuss Crosby with you if you have questions or if anybody has sort of final thoughts about Crosby. Questions? Issues? Everyone feel like you've got it now? It all makes sense? It's clear? If you'd like, we can talk about Crosby now, but we don't have to if you don't have any questions, because I think I've said most of what I had to say. Yeah? You sure? Is that your hand? No, that's not your hand. Okay. Well, then let's talk about the Arctic then. Your cat's on fire? What? Interesting. He must have just gotten an email or something. I'm pretty sure he said his cat's on fire. Either that or he really doesn't like this subject. The Arctic. What's going on in the Arctic? The sea ice, well, right this second it's not melting, right? This is the cold time of year up there. Chances are it's in fact freezing right now. But the big trend is that it's melting. This is from very recently, just last month, Arctic sea ice extent. So the amount of the Arctic Sea at the North Pole that's covered in ice is now lower than it was at this point during the record-breaking 2006-2007 cycle that resulted in the record lowest sea ice extent ever recorded in the summer of 2007. Well, the summers of both 2008 and 2009 saw extreme melting far in excess of average. Neither quite reached the extent of 2007. So what we're talking about here is that, well, here, I'll skip ahead. I think there's a better one. Here's a graph of it, for example. On the left here, the extent of ice, millions of square kilometers, beginning in October, when it starts to expand, through February. The black line indicating the average amount of ice frozen at each date over the 1979 to 2000 period. The green dotted line is just the data for 2006, 2007, which by the end of the following summer was the smallest ever recorded amount of sea ice. And the blue line indicating what's going on this year. So where the sea ice is now, how much sea ice we have right this second. And you'll see that it was lower than that previous low when it started in October. It got a little bit ahead of it there in late November, fell back, and now it's basically on course, very similar and a little bit below what it was in 2006, 2007. The two pictures on the right, the minimum amount of ice in 1979, which is typically, it's about the end of August or the beginning of September when you have the least ice in the Arctic Sea. It's done the most melting, and then it starts getting cold again, and it stops melting back. So in 79, it looked like that, and in 2005, it looked like this. And you can see that instead of reaching all the way to the north part of Asia, Siberia, there's a huge open path of melted, thawed water, blue. And similarly, you can see more, but only slightly more perhaps, through the Northwest Passage above Canada. Now let's go back here. Why does this matter? Because there aren't enough places where you can wear your swimsuit and look at glaciers, and we're going to have more of them. It's going to be very exciting. The tourist opportunities are enormous. Actually, I'm not entirely kidding, but let's look at this more. Arctic to be ice-free in summer in 20 years. Here again, this is from very recent news reporting about scientific papers that have been published very recently. And one of the prominent climate scientists has predicted that in 20 years there will be no ice in the Arctic Sea at the end of August, beginning of September. That's newsworthy because previously we thought it was going to take like 40 or 50 years or maybe even 100 years before we would get to that point. And now the expectation is, judging from the trend, that in fact we will see no ice in the Arctic by the middle of summer in as little as 20 years, according to this scientist. And from the article about this paper, sometimes referred to as the Earth's air conditioner, the Arctic Sea plays a vital role in the world's climate. As Arctic ice melts in summer, it exposes the darker colored ocean water, which absorbs sunlight instead of reflecting it, accelerating the effect of global warming. Are you all familiar with this process? What is this called? Anybody know the term, the scientific term that refers to this phenomenon? Albedo. The albedo effect. If the top of the Earth is covered in ice, which is very, very white, that ice reflects sunlight, the radiation from the sun, back into space, which reduces the overall amount of radiative forcing, radiation that the Earth is holding within its atmosphere. If, on the other hand, the ice melts and it's dark blue water, it does not reflect nearly as much radiation back into space as it did when it was ice. It, in fact, absorbs radiation and warms up, holding heat inside the atmosphere and raising the overall radiative forcing on Earth. So what this represents, potentially, is a positive feedback, which is not to say that it's a good thing. It's to say that it's self-reinforcing, right? The hotter the Earth gets, the more that ice will melt. The more the ice melts, the hotter the Earth will get. And we will see an acceleration in the effects of global warming as the Arctic sea ice cap melts. Anybody concerned about this? Is this one of the things you lie awake worrying about? Yeah. Yeah? Okay. So there are a couple of you. Maybe three? Nobody else? You? Okay, we're up to about 4 or 5. Okay, we have a lot of work to do then, I guess, to persuade you to be concerned about this. What are some of the reasons we might be concerned about this? Yeah.
Adding more fresh water to the ocean, disrupting the salinity level.
It's adding more fresh water to the oceans, which can disrupt patterns, currents, and the movement of energy in the oceans. This is true. This is particularly a concern off the southern tip of Greenland and in the North Atlantic. And actually, we'll get to that in a few minutes. What else? I mean, some of you said you are concerned. Why are you concerned? What concerns you about this? This is a long way away. It's really cold.
Like the Netherlands would be completely underwater.
The Netherlands might be completely underwater.
And like parts of Florida.
And parts of Florida.
It's not good for people who live there.
Okay. You remember that slide I showed of what the coastline of the southeastern United States looked like when in between ice ages, when the sea level was higher than it is now. There's a lot of what's now Florida that will be essentially part of the ocean. Yes?
What's the difference in the sea level between the lowest amount of ice to the highest?
The difference in the sea level between lowest and highest amount of ice. Anybody remember from that slide? Which lecture was that? I think it's several hundred meters.
Like every year. Like
Oh, no. Oh, I'm sorry. No, I thought you were talking over glacial, interglacial cycles. Every year, the amount of...
like when the ice melts in the summer, how much higher is the sea level?
Good question. When the ice melts in the summer, how much does it raise sea level?
Well, actually, I don't think it's the sea ice that's the problem because it's going to the same amount of volume.
Okay.
But it's the ice caps on the land.
Okay. Very good. When the sea ice in the Arctic Ocean melts every summer, sea level worldwide rises none. Nil. It does not change. And the reason that is that all that ice is floating in the water anyway. So as it forms, it simply displaces water of equal weight. And as it melts, the water, it readjusts. So that doesn't change sea levels at all. It's only the ice that's on land which, if it melts, will raise sea levels. And that is a significant concern. And here we're actually, when we talk about that, what we're really worried about in the North Pole is Greenland. And we'll talk about Greenland in a moment. Any other reasons why we might care about this? Yeah? The polar bears! Absolutely! We're talking about basically wiping out the polar bears. Or at least that's as best as we can figure. If there's no sea ice in the Arctic in the summertime, chances are that the polar bears will not make it. Or if they do, they will only make it by essentially retreating to land. And if they do that, the problem is all the land is getting warmer and warmer and warmer too, right? They may, in fact, find that the habitat conditions they need are simply not to be found. And the polar bears, in fact, have recently been petitioned for listing under the Endangered Species Act in the United States. I believe that petition was successful. Is that right? I don't know. The Fish and Wildlife Service this is the kind of thing that makes the Fish and Wildlife Service wish it didn't exist, right? This is the kind of decision that the science is overwhelmingly clear what they should do, but the political ramifications of actually doing it are absolutely unacceptable, right? Which is to say, if they list the polar bear, arguably the law will say that the government must take whatever steps are necessary to protect the polar bear from going extinct. And yet the only step that we think really will prevent the polar bear from going extinct is to stop burning fossil fuels. And let's face it, it's going to be hard getting that one through Congress, right? Congress is probably going to stand up and say, well, let's amend the Endangered Species Act and simply say somewhere in a paragraph, this doesn't apply to polar bears. I would predict that is what Congress would do if it were really forced at that kind of level of logical coherence, right? But actually, it probably just won't be. They'll probably come up with some plan to like airlift polar bears to Antarctica or something like that so that we can save them that way instead. And that's only a little bit facetious when I say that. Why else would we care? Yeah?
Like storms like hurricanes and tsunamis and stuff like get worse.
Okay. Storms, hurricanes are expected to become more intense under, as temperatures increase under global warming. That's a reason to care about global warming. It may or may not be specific to a reason to care about the Arctic. But I guess the final thing I would add is that one really good reason to care about the Arctic is that it is a magnificent early warning system for the rest of the world with respect to climate change. If you have doubts about climate change, the Arctic is a really good place to go and look and see whether you should believe this. Because according to the models, temperatures will rise much further and much faster in the Arctic than they will down around here. And this is, in fact, what we're seeing. To that extent, it's also a nice place to go and sort of imagine how much change could be brought by a simple ratcheting up of temperatures by, let's say 4 or 5 degrees, 5 or 6 degrees Fahrenheit. Doesn't sound like that much. It's already happened up there. So we can go and look. What else? So anyway, another map here. The yellow line depicting the average, the median sea ice extent in September from 1979 to 2002, and then the white in the picture depicting that late summer of 2007, when the sea ice reached its previous minimum. And you can see there that by that point, the Northwest Passage above North America was pretty much ice-free. And you could make it pretty much anywhere you wanted to go. There wasn't that much in your way in the way of ice. We've talked about this already. Let's talk about Greenland for a moment. How much ice is on Greenland? Anybody know? There are a lot of different ways of measuring it. How thick is it? Anyone know, roughly? How thick is the sea ice, by the way? The sea ice, we'll actually see a picture of it here in a moment, but the sea ice in the Arctic Sea itself isn't that thick. Anywhere from a foot or two to maybe 6 or 10 feet thick. The ice on Greenland, who's got a guess? Yeah. 2,000 meters. That's in the ballpark. We're talking like between 1.5 miles and 2.5 miles thick. If all the ice on Greenland melted, sea level would rise worldwide by 16 feet. And that would be enough to put, say, Miami underwater and a lot of coastal populations. So we have a lot of reasons to worry about this, about that ice staying there. The map on the left is the pink on each of these maps indicates areas of melt from this colossal sheet of ice in 1992. And the pink on the right-hand map is the same, but for 2002. So we see in just a 10-year period an incredible increase in the amount of melting going on in Greenland in the summer. In the past decade, surface melting of glaciers around Greenland due to warm air temperatures has increased in both magnitude and area, while snowfall has increased just slightly. The result is a tripling in the amount of ice mass lost in Greenland between 1996 and 2007. We're talking about quantities of ice lost in the billions of tons. sort of bouncing back and forth between the Arctic and Greenland here. Maybe I should have ordered these slides slightly differently. Let's go back to the Arctic Sea for a moment. The graph here on the right, all of the dotted lines and the big red line were the projections made by the IPCC, the Intergovernmental Panel on Climate Change, when it sat down in, this must have been the 2002 IPCC. I'm not sure which one it is. Anyway, they predicted. They said this is how much we think we will lose sea ice in the Arctic in the next century. And all those different lines represent different models. And the red line is the average of all the models that they use to project this. And so you can see sort of roughly what we thought the range of possibilities was as far as the rate of sea ice loss in the Arctic. And the black line is what's actually happened. So you can see that in a very short period of time, the actual rate of loss of sea ice has already gone way outside what we thought might possibly happen under various scenarios and models of the IPCC. So this is just to say this is happening much more quickly than we anticipated. The map at the top depicts the relative portion of the Arctic sea ice that is new that year, that just froze that year, versus ice that froze 1 or 2 years ago, versus ice that froze more than 2 years ago. Which is simply to say how much of this ice is actually persisting all the way through the summer and remaining and then becoming a sort of basis on which more ice can form the following year. And the point is that compared to the average between 1981 and 2000, 2009 shows ice that even if it's there, is almost entirely brand new ice that year, which is going to be much thinner and much more likely to melt than ice that is older than that, right? It's a way of depicting the fragility of the ice that's there, even if it appears to be covering the sea in significant measure. And then the lower graph simply charts this out over the period 81 to the present. The relative portions, you can see that whereas 1-year-old ice was only about 50% previously, it's now in the ballpark of 75% of all the ice at the maximum extent of freezing. Oh, now we get to see a neat little movie. This is a way to get at that question of thickness. How thick is the ice over the course of a year? Here we are, it's September, mid-September, so this is probably the minimum. Only the red spots are ice thicker than 6 meters or 5 meters roughly. So that would be what, about 15 to 20 feet thick. Most of the ice is in the ballpark of 3 meters, so that's maybe 10 feet. And you can watch this as it retreats, melts, contracts over the course of the summer. And again, we'll talk in a moment. The reason that a lot of people in the world are concerned about this, or rather, actually, there are a lot of people in the world who, believe it or not, are excited about this. And the reason for that is the possibilities of shipping. If you look around the perimeter of the Arctic Sea, if that's open ocean, even for just a couple months, the opportunities for using those routes for shipping are extraordinary. And we'll talk a little bit later about that. So in many ways, it's not, from their point of view, it's really a question of, is there enough water around the edges of the Arctic Sea for at least a long enough period of time we can count on it being navigable, then people are going to move to make that, to take advantage of that opportunity. And in many ways, that's what's brand new, right? Because basically, as long as humans have had the technology to think about going anywhere on a boat, let alone taking anything with them, the Arctic Sea has been impassable, right? It's basically been filled with ice all the time. even at the end of August, if there might be some open water around the edges, but it was not something you'd want to go try to sail through, given the amount of icebergs and other dangers that you would have to encounter. What we're seeing now is a situation in which it's becoming safe and it's becoming predictable. Any questions? So what's going to happen? This is a headline from 5 years ago from the New York Times. As polar ice turns to water, dreams of treasure abound. And the article provided a kind of overview of the commercial opportunities represented by the disappearance of the Arctic sea ice. It said that it's estimated that 1/4 of the world's undiscovered oil and gas resources are in the Arctic. There are lucrative shipping routes. There are new cruise ship destinations. Just what we need. I'm so tired of the old ones. There are important commercial fisheries. And given the state of the fisheries elsewhere in the world, any fishery that's in reasonably healthy condition is worth thinking about if you're in the commercial fisheries business. This has continued. This one is from just this week. Melting Arctic ice clears way for shipping, fishing, oil drilling, and major problems. There was a meeting of the American Academy of Sciences in San Diego this past week, and they had a panel discussion on this subject. And so this is a report about that discussion. An Arctic largely free of ice during the summer will mean new opportunities for fishing, oil and gas production, and shipping in an area that is both extremely sensitive ecologically and highly unregulated. The United States, Russia, Norway, Denmark through Greenland, and Canada have jurisdiction over Arctic waters within 200 nautical miles of their coastlines. This creates a haphazard patchwork of regulation and is worrisome if countries, namely Russia, have lax environmental standards. So you remember the discussion we had about sovereignty and property and territoriality? This is a case in which basically we haven't needed to worry or think or concern ourselves with property, territoriality, sovereignty in the Arctic because apart from a significant but relatively small number of people who lived up there, there wasn't really anybody who cared one way or the other. The only reason that these 5 countries have jurisdiction over Arctic waters within 200 nautical miles of their coastlines is because that's the rule everywhere else in the world. Right? You have jurisdiction, which is to say some kind of legal authority, some kind of sovereignty over the open seas 200 miles out from your coastline. And that's actually a fairly recent extension. It didn't used to be that far. I think it was about the 1970s that the United States decided they wanted it to reach that far instead of the previous like 50 miles or something like that. And we just said, oh, by the way, we're claiming another 150 miles of ocean all the way around our coastline, and the rest of the world eventually had to come around and say, oh, okay, fine, then that'll be the rule. But previously it didn't matter in the Arctic. I mean, you could put it on a piece of paper, but it didn't really matter. It wasn't even really clear exactly where the coastline was necessarily because it was all under ice anyway. So this is playing out right now. There are simultaneously political efforts to figure out what the sovereignty picture, the territoriality of the Arctic should be. That's a source of, or it's an arena of active diplomatic debate right now. And there's also a lot of movement and maneuvering to figure out property claims in the Arctic. And what's useful about this case for our purposes, apart from the fact that it's worth paying attention to global warming, is that we get to watch this. We can actually see this playing out, and we can think about why is it that you need both of these types of territorial maneuvering together? Why is it that you can't really resolve property claims without some kind of sovereignty framework? Why is it that that no one really has any reason to figure out a sovereignty framework unless there are property claims at stake, right? You have political arrangements having to do with sovereignty and these different nation states, and you have economic arrangements having to do with property and access or claims to resources. If you want to go tap into some of that oil and gas in the Arctic, and say you're a big oil company, you need some kind of assurance that you actually have a right to do that, right? That there's some place you can go and you can build some platforms and drill rigs and put them all in place and start getting that oil and gas out of the ground. But you need to know that whatever political authority claims that space will recognize your right to be there. And if it's not clear who that political authority is it the Danish government? Is it the US government? Is it the Canadian government? Then you don't really know whether you're going to be assured of your property claims to that rig and that drill and so forth, right? On the other hand, the Danish and US and Norwegian and Russian governments, previously didn't really need to care about this area because even if there were lots of resources there, you couldn't get them. You couldn't get to them. So they were, in effect, not there as far as needing to resolve sovereignty questions. So this fitting together is what I'm getting at. Okay? Are there questions about that? How many of you have taken a class in global warming or feel like you have a solid grasp of why it happens, how it's happening? So just a few of you. Okay. I thought that might be the case. So here's a little side detour into the question of global warming more generally. And here again, it's useful to think about this in terms of the temporal scales of the processes involved. So here we're doing big, huge temporal scales. These are graphs going back 400,000 years depicting temperature change in the bottom graph relative to normal, relative to the present, in centigrade. The top graph over the same time period is CO2 concentration in parts per million, which has been reconstructed from the Vostok ice core. This is another reason to care about the Arctic, or specifically to care about Greenland. All that ice turns out to be the best known repository of data about the Earth's atmosphere for this kind of time period. Each layer of ice got laid down in a given season, right? A given year. They're layered just like the layers of sediment in a floodplain, perhaps also comparable to the layers of tree rings in a tree. And inside of each layer of ice are little teeny, teeny, tiny ice or air bubbles that got captured in that ice. And the air in those air bubbles is unchanged from the point in time when it was captured in the ice. So we have 400,000-year-old air in these bubbles, and we can analyze that air and figure out how much CO2 was in the atmosphere in each year, or at least in intervals, very fine intervals, like a year or 5 years, that kind of thing. And because all that ice has been forming and building for such an incredibly long period of time, we've got a record there that is remarkably intact, remarkably reliable. And it would be a shame if it all melted away and we didn't have the data anymore, right? It would be a loss to science. And the best ice cores have been found in Greenland, the most intact and the oldest. I believe that there may also be some very good ones in Antarctica. But a lot depends on how well they've been laid down and preserved over time, and then also how easily we can get there and actually drill these things, because you have to drill like a mile or more down into the ice and pull the whole thing out and take very good care of it. Anyway, you can see from looking at these graphs that there is a remarkably consistent, tight correlation between the amount of CO2 in the atmosphere and the temperature of the Earth. Okay? This is just to demonstrate that we know this not only from first principles of physics and chemistry, but empirically, going back at least 400,000 years. Anybody know which one causes the other? It's a trick question. We know that they correlate. We know that they are related to each other, but we don't really know exactly what the principal driver or causal force is. In other words, we know that when CO2 concentrations go up, as they have at various points in time, temperatures are also high. And we also know that CO2 concentrations are rising now well above what they have ever been in this time period, right? So the highest CO2 concentrations we see in the last 400,000 years from the ice core were about 310,000 years ago, and we're just about 300 parts per million. What is the CO2 concentration in the atmosphere now? Anybody know? 384. That's about, yeah, it's somewhere between 384 and 387 right now. So we are already well above any level that's been seen in the last 400,000 years. On the other hand, that's not to say that we know that the rising CO2 somehow caused the rising temperatures previously. That's a fine point and perhaps doesn't need to be belabored right now. Any questions? So here's what's going on in the last 150 years and also over the last 1,000 years in terms of CO2 concentrations in the atmosphere. Again, parts per million. You can see that it hovered between 280 or 270 and 290 for the better part of the last 1,000 years. It started climbing in the 1800s and in earnest in the 1900s, and is now, it's actually higher than that graph now. It was at 360. It's going up about 4 parts per year right now, parts per million per year. Over the last 200 years, you can see the ice core data is what gives us these numbers until about 1960, 1956 or 58, which is when we started measuring this directly in Hawaii, and you can see how it's climbed since then. All right, shall we take our break? All right, 5 minutes. Okay. This is the famous hockey stick. Actually, not a hockey stick. They call it the hockey stick because it looks kind of like a hockey stick. This is Northern Hemisphere temperature anomalies relative to 1961 to 1990, which is just to say compared to the average temperature between 61 and 90, which is the line through the middle at 0. What have the temperatures in the Northern Hemisphere looked like over the last 1,000 years? And we can see that they've gone up and down. The black line is a smooth sort of average through all of these data points. The reconstruction from 1,000 to 1980 is based on things like various kinds of proxies, such as those ice cores, that give us ways of inferring what temperatures were like in different parts of the world at different points in time, going back in time. Tree rings are another, that sort of thing. Actually, the shells, teeny little shells embedded in sediments in the bottom of the ocean, are another really good way to reconstruct these. You can see the gray is there to indicate sort of the range of blurriness in the data. In other words, how much uncertainty there is, what the range might be within which we are comfortable we've got this nailed down. And of course, the further back in time you go, the larger that range is likely to be just by the nature of the information available, right? So as you can see, as we get closer to the present, that spread gets smaller. We can see temperatures going up and down. There's been significant variation in temperatures, but on the order of ½ degree centigrade. And then in the last, say, 30 years, we actually can in the last 100 years or so, we can rely directly on instruments, measurements of temperature that were recorded over time. So the error or uncertainty becomes very small, and we start to see the temperatures climbing towards the end of the 20th century, and the continuing to climb now well above not just average, but anything that was previously considered to be within the realm of possibility for the last 1,000 years. I shouldn't have made this so big. Perhaps it's too blurry, but reconstructed temperature, again, over the last 2,000 years, various data sets generate different lines here, but they tend to move more or less together up and down. The medieval warm period is a period of time when temperatures were a little bit warmer than normal. It was followed by the Little Ice Age in around 1600, a period of time when temperatures were a little bit colder, and then rising very significantly, again, much higher than anything previously recorded in this time period. Those are all averages, right? That's averaging for the Northern Hemisphere, or averaging for the world as a whole. But obviously, the effect of this is not the same everywhere in the world. This is a map depicting the relative surface temperature changes over the last 30 years or so in different parts of the world. And as you can see, it's the higher latitudes, especially in the Northern Hemisphere, where temperatures have risen the most. And this is what's already happened, okay? So we're seeing a rise of 2 to 4 degrees centigrade at the Arctic and much of northern Asia, northern North America. There are other parts of the world that have also seen that amount of warming, such as in Africa and the Amazon. But then over the oceans, you actually see that temperature has been stable or even dropped in this same time period. Or not all the oceans, but some of the oceans. And in most of the temperate world, the rise in temperatures has not been as pronounced as in the Arctic. And this is why, again, it's worth using the Arctic or thinking about the Arctic as kind of further along in this process of warming and therefore illustrative of the kinds of things we can expect. It's also worth just noticing that the parts of the world where the wealthiest, most powerful people happen to reside are not the parts of the world that are going to bear the brunt of this in the short to medium term. The worse implications or the faster changes predominantly are going to occur in parts of the world where people are either not very numerous or not very powerful, or both. This also can be thought of in relationship to precipitation patterns. Here we get change in overall average annual precipitation 1976 to 2005. The red colors are areas where precipitation, rain and snow, have declined. The green areas are places where it's increased. And you can see, again, it's not at all evenly distributed around the world. Much of sub-Saharan Africa has seen a decrease. Much of the Amazon and South America have seen a decrease. The western and southwestern United States have seen a decrease. But in northern Siberia, northern Russia, a lot of other parts of the world, you can see significant increases. It's interesting that there are places in Asia where you've got significant increases right next to significant decreases, right? Which has to do with the movement of the monsoon patterns in relationship to atmospheric pressure and temperature. So the oceans, which absorb roughly half of the CO2 that we've emitted, are in the ocean, rather than in the atmosphere. Temperatures in the ocean are changing. That has significant implications for weather patterns at global and sort of continental scales. Just to emphasize again that this is, it's an unequal process, even if we frequently think of it in terms of averages over the entire world. All right, questions? Yeah? You got a question? Well, I mean, it depends which kinds of effects you want to focus your attention on. In terms of agricultural productivity, for example, agricultural production, the studies have found that the more severe impacts to agriculture from things like droughts are likely to happen in lower latitude places, which tend also to be already more precarious in terms of drought and water resources, and also tend to be poorer countries with less money available to do things like drill wells and put in irrigation systems. So the impacts to agriculture are expected to be more severe in the poorer parts of the world than in the wealthier parts of the world. And there are even parts of the developed world where rising temperatures might actually benefit agricultural production. So if you think about parts of Canada, for example, you know, raising temperatures 3 or 4 degrees would mean much longer growing seasons, might not mean reduced rainfall, might enable them actually to grow crops in places that previously couldn't grow those crops, that kind of thing. Yeah?
That one chart that had kind of like the cycles of like,
Which one?
back. That one.
Yeah.
Doesn't it kind of look like global warming doesn't look that strange if you compare it to the other like really warm periods in the world's history?
Okay, good question. Doesn't it look as though maybe the world's been through this kind of swings in temperature in the past, judging from this? I mean, and what this is mapping out for us, in part, is ice ages, right? You've got periods of time when it's much colder down here and lower CO2 concentrations, and then it warms up. And in fact, this ascent right here at the end is the end of the last ice age, right? Which is, well, what we've been talking about in the course. All of this domestication of agriculture and this flourishing of cities and the growth of the modern world has all taken place in this little piece at the very end here where temperatures, I promise I'm going to get a new battery today. This thing right here. The entire story of the rise of domesticated agriculture and modern civilization happens in that little spot with nice warmer temperatures. Now, on the one hand, you're right. The world has gone through temperature swings forever, and that shouldn't surprise us. The thing that's different is that we're not seeing what we're experiencing right now. It's not like we were here and global warming is causing it to go up here. We already were here. We already were in a warm period, and global warming is going up above this range here, right? To get to a point in the Earth's history when temperatures were as high as they are now, if you go back in time and you say, I want to go until I find a time when the Earth was this warm, as it is now, and as when CO2 concentrations were as high as they are now, how far back do you have to go? It's about 3.5 million years to get to a time when it was this warm again, or previously. So what we're seeing now, yeah, climate changes, no question about it, over these kinds of timescales. But what's happening now actually is extraordinary compared to anything in the last 3.5 million years. Yeah?
In 50,000 years or 100,000 years, will the temperature inevitably go down again?
Will we go into another ice age in the next 50 to 100,000 years? There's every reason to believe that we would in the absence of fossil fuel burning and the changing. Yeah, I mean, believe it or not, there was actually a point in the 70s when the scientists of the world were worried that we were about to go back into an ice age, that we were sort of due to go back into an ice age because we'd had as long as you could expect from a nice, warm interglacial. And they actually wrote the president and tried to get him agitated and concerned about this. It was President Nixon. But it was only about that very same time that it became clear that, in fact, the forcing from fossil fuel burning and CO2 emitted into the atmosphere might override the onset of another ice age and, in fact, might drive the system in the other direction. So it's not clear. I mean, given the things that we believe cause ice ages, yes, the world ought to be expected to go into another ice age. But the CO2 in the atmosphere is now much higher due to things that humans have done, so we don't know whether that'll actually happen. Okay. So let's talk about the Arctic again in relation to this in terms of these commercial interests. This is a map from that New York Times article 5 years ago depicting potential routes for shipping through the Arctic if it were to be free of ice for significant periods of time every year. So the key thing here is that the value of these routes is determined relative to the value of the alternatives, right? Which is to say, the opportunity to ship goods through the Arctic is only as attractive as it is faster than shipping them some other way, right? And so down here in the lower right, if you're trying to make your way from Tokyo to London with a tanker full of some good, and you have to go through the Suez Canal, which is to say you start in Tokyo and you go south around India and then up through the Suez Canal and the Mediterranean and get to London that way, you're talking about 13,000 miles that you have to travel. But if you can go through the North Sea, it's only, I think that's 6,000 miles. So it's less than half as far if you can go through the Arctic Sea. Similarly down here, if you decide to go the other way through the Panama Canal compared to the Northwest Passage, the difference again is about half. 15,000 miles through the Panama Canal, 8,600 miles, 8,500 miles through the Northwest Passage. Are there any questions about this? And this is overlaid again with estimated sea ice extent. 5 years ago, we thought that it would retreat to that white area in the middle only by 2070. And now we're saying the best guess is more like 2030, maybe 2050 at the outside. There may not be any ice at that point. What else is on this map? The dark areas, if you look in the upper right, the dark sort of orange blotches are areas of known and prospective oil and gas reserves. You can see enormous amounts in the Barents Sea above Scandinavia, a great deal in northern Russia, and also northern Canada and Alaska. We already tap into some of those oil reserves around Barrow. Now, again, the issue, that's what the issue is, right? There's a lot of valuable resources that are now available that hadn't been before. So that and the shipping are the principal commercial issues at stake here. This is just a blow up of that middle part. Again, those estimates have already been revised. There are about 150,000 Inuit, Eskimos, who live in North America or in the Arctic above North America. These were discussed in this article from the New York Times. These are people who are very much threatened by the changing temperatures, both directly and indirectly, right? Directly, they're threatened because many of them, most of them make their livelihoods from largely the fish and the wildlife. And those livelihoods are imperiled as these animals, organisms, either lose their habitat altogether or their habitat moves and they are no longer where they used to be, right? Some of the most compelling stories about actually observed climate change come from these Eskimos living in the Arctic. They're also indirectly threatened, and that's what this woman who's a leader of the Inuit is talking about when she's talking to the New York Times. As long as it's ice, nobody cares except us, because we hunt and fish and travel on that ice. However, the minute it starts to thaw and becomes water, then the whole world is interested. And they are trying to assert themselves, demanding both action with respect to climate change and also a seat at the table in these negotiations over oil and gas concessions and road building and shipping and infrastructure for harbors and that sort of thing. As of 5 years ago, these were the investments that had already been made, according to the New York Times. A lot of shipping companies were investing in double-ended tanker ships, which is to say, why do you need a double-ended tanker ship to go through the Arctic Sea? Any idea? Yeah. If you get stuck in the ice, you can turn around without having to turn around. Exactly. You can throw it in reverse, and I mean these boats are even if the ice melts, you still have to be prepared to deal with floating bits and pieces, chunks that can be quite large of this ice. Maybe not iceberg size, right? Because these aren't necessarily pieces that have dropped off of glaciers. But we're still talking about a layer of ice that might be, you know, anywhere from 3 feet to 15 feet thick. If you get trapped in such a bunch of ice, you don't want to have to turn around to put your bow in the other direction. You want to just be able to back out. Norway has put $8.8 billion into natural gas exploration and development. Russia has put in roughly 2 to 2.5 times that. Oil is expected to be still a greater opportunity than natural gas. Canada was putting $60 million into developing a shipping route through Churchill, Manitoba. There was a funny interview with a man, actually an American man, who had bought a big piece of land in Churchill, the old port, for like $1 because no one had thought it was going to be worth anything, and he was rapidly preparing to invest in creating the infrastructure needed to actually expand and put in a modern shipping facility at Churchill. Fishing, shipping, military research, there's a lot of activity in the Arctic now that wasn't going on previously. Here are those routes. Oh, now you can read them. Okay, territoriality and sovereignty then. How is this going to get resolved? This is actually a point of active diplomatic maneuvering right now. This is a depiction of what countries have now under the current framework of international law pertaining to offshore lands or open sea territorial waters, right? So the red shaded area in the middle is sort of what's up for grabs. It's not clear who has what kinds of claims in these areas. what did anybody, who heard what Russia did a couple years ago? What did they do?
They took a submarine and planted a flag inside a container and
They sent a submarine to the North Pole, and they planted a Russian flag on the North Pole under the water of the Arctic Sea. I mean, this is the kind of thing it takes, or once upon a time, this was the kind of thing that signified to the world that you had staked a claim, literally, staked a flag. I mean, if you go back and read this, it's the same kind of thing that Columbus did, right? There's somehow Europeans got this notion in their head that if you land someplace and you want it, you just put a flag up. And that's somehow, I mean, if only it were that simple. But nonetheless, it still carries enough significance, symbolic or otherwise, that the Soviet or the Russians felt that this was a worthwhile use of their time. All right. So generally, as I said before, coastal countries control the sea. It says here 230 miles from their shores. That might be that's 230 miles like we normally think of them. I think that's 200 nautical miles, as in the previous slide that mentioned this. Like the U.S. controlled area here. So the areas behind these black lines roughly indicate where each country has sort of established claims, right? And again, the reason Denmark is involved is because Denmark is technically the sovereign of Greenland. The area of the hatched, the sort of diagonal stripes, not currently part of any country. Nations can make claims in the area, which must then be approved by the United Nations. Anybody know the basis on which a country can make a claim beyond 200 nautical miles from their shore? What do you have to do? Okay, you're right. The next paragraph there explains it. Must be proven that underwater ridges here are part of a continental shelf rather than a separate feature of the seafloor. So literally, this is like tectonic plates matter, right? And there are people, including the U.S., who are actively mapping the seafloor in the Arctic to try to figure out exactly how far out their continental shelf sticks, right? Generally speaking, you get to the ocean, you go off the edge, you're on the continental shelf for some distance, and then you're no longer on the continental shelf, and the ocean gets a lot deeper. Well, it turns out that you can, under the current framework, you can assert claims further away if you can find a ridge that appears to connect you to connect that piece of open sea underwater to your continent. Now, that leaves still this area in the middle that people are trying to figure out what to do with. And suddenly, it's no longer good enough just to say, oh, it's international waters, right? That would be the default position, except that leaves all these oil and gas reserves unassigned, so to speak, right? It becomes extremely attractive for different countries to assert claims over those areas. So here's one method. The median line method would divide the sea into areas proportional to the amount of coastline that each country has. So you map the coastline and you add up the total and divide by each country's share, and then you draw a line, draw a bunch of lines through the Arctic Sea and divvy it up accordingly, which would, of course, give Russia an enormous amount of the Arctic Sea because it's got an enormous coastline. There's also a sector method being proposed in which you divide it along lines of latitude up to the North Pole, in which case how complicated your coastline is no longer so important, right? A complicated coastline would give you lots of coastline and therefore more land or more sea under the previous method. Here it would just be straight divvying it up according to lines of longitude. Anybody been to the polar bear cam? This is the other big player, actually, believe it or not. The oil and gas are enormously valuable and attracting a lot of attention, and there's no question. I mean, at the end of the day, this is perhaps the sickest part of it all, is that global warming is creating business opportunities for oil companies, right? It's enabling us access, giving us access to huge amounts of fossil fuels that we otherwise wouldn't be able to get to. And that will only make it more certain that global warming continues, right? If there's another major player at the table, economically speaking, it's actually probably going to be tourism. I mean, apart from just simple environmental activism. And this kind of thing, any thoughts about polar bears? How many of you really feel like the polar bear has some kind of moral claim on us that makes you want to act, makes you more agitated? Yeah? It's been your favorite animal forever. Excellent. How many of you feel like the polar bear is cool, but it's really just not that big a deal compared to everything else that's going on with global warming? Now, come on, you got to have an... You? 1, 2. So now we got 2 people who... How many of you think polar bears just aren't cool at all and you don't want to have anything to do with them? All right, I'm not getting any votes here, folks. I just find it interesting because there are, it appears, quite a few people for whom this polar bear is the thing that's going to make them care, right? Or it's going to make them care in a way that otherwise they would not about these issues. Yeah? Okay. Okay, so the polar bear matters from an ecological point of view for you as a keystone species, so to speak, and has ramifying implications for the larger ecosystem, rather than just because it's charismatic and it's big.
I think that people will pay attention to it because it's a cute animal. Like if this was like a great white shark, people would be like, whatever, kill it. We don't like it.
Okay.
Because it's cuddly.
Their cuteness might save them. I mean, I think it's very interesting that first thing, it's interesting that you can pay money and go take a ride in one of these buses, the Tundra buggy. It's also worth noticing that they don't let you get anywhere near those polar bears when you ride in the Tundra buggy, right? Polar bears are perhaps the most aggressive predator on man that still exists in this world. I mean, polar bears will actually hunt humans, which is simply not true of pretty much anything else, right? Nonetheless, they are very cute, and they also are genuinely threatened by this. And so if you want to see a polar bear, you probably ought to book your ticket on the Tundra buggy sooner rather than later, because things don't look good up there, okay? All right, that's it. We're done for the day. We will